Alright, in this video we're going to introduce the idea of sequences, and hopefully I can draw you back to some elementary ideas to make you feel like it is not as hard as you think it is. Because it's really not. You just have to make some connections. So, a sequence is, and this is my definition, a list of numbers or other objects that can be obtained by a pattern repeating. So, some pattern. And you're familiar with these because you had these in elementary school, and you've seen them online, I'm sure, different places like IQ tests and stuff like that. They want you to keep the pattern going because math is about patterns. So in the first one, 2, 4, 6, 8, who do we appreciate? No, not that. We want 2, 4, 6, 8, 10, 12, 14, 16, 18, so on. So the even numbers here. The next one, triangle, circle, square, triangle, circle, square, hopefully. So there's a pattern there. And that's not numbers, it's shapes, but you can get the pattern going once you see it. And then happy face, sad face, I don't know what to call that one, straight face, happy face, and then you should be going sad face, and then straight face again. Alright, so you can tell patterns. You're aware of these and you've seen them, so you just have to get your brain on pattern seeing. So math's all about patterns. You just have to open your eyes to them and be willing to look for them. And when you find patterns in math, you find how to understand the world, because the world is made up of mathematical patterns, even if you don't want to admit it. So, here's your general breakdown of a sequence with notation. So, let's say our sequence is 1, 2, 3, 4, and then so on. Well, first off, the so on I just said, the dot, 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 I've underlined in red here, those are called ellipses. And it just tells me that this sequence goes on forever. There's no ending point. So if ever you see the dot, 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 the ellipses, that means this sequence is just infinite. It goes on forever and ever. Alright? Underneath each number in the sequence, we can call them with an A. A for, I guess, just start of the alphabet. You can probably use anything, but we use A in math a lot. So A, and I call it sub 1. Sub means below, so think sub, below. So A sub 1 means that the number 1 I'm pointing to is the first term. A sub 2, the 2, is the second term. The third term we call A sub 3, which is 3. The fourth term, and so on. So we could keep going, A sub 5, A sub 6, it's just the term number basically you're referring to. Alright, so for instance, in green, A sub 7 would be the 7th number in the sequence, and for our specific sequence here, if you keep it going, A sub 7 would equal 7. A sub n is the number you are looking at in a sequence where n is greater than or equal to 1, meaning we're not going to start counting our sequence at 0. I'm not going to say the first number appearing as the 0 term. I say it's the first term. And is the sequence number that is in the spot or the blank that I'm looking for. So if they say go find A sub n in a sequence, they're asking you for the theoretical last term. Where would that last blank be? Alright, so let's keep going. Alright, so here I just want to give you a perspective real quick on what we call subscripts. Like I said before, it's sub something, so A sub 1, A sub 2. So this term right here, we could say not just as the first term, it's the A sub 1 term. This is the A sub 2. This is the A sub 3. Well, if this is the first term that I've labeled A sub 1, then what would that make this term back here? Well, if you look at how we're calling term numbers, they go in chronological order sequentially. So if we're going 1, 2, 3, well, to go back 1, I'd have to subtract 1. So this would actually be my 0 term. Even though we don't start there, it's going to become useful in writing equations later. So this is actually my A sub 0 term. Alright, and likewise over here, if this is 1, 2, and 3, and then I've got a blank that I haven't labeled, this one would be my next one in line, my fourth term, so this one would be A sub 4. So what I'm doing to get from one subscript to the next is I'm just adding 1. So for instance, to get from A sub n to the next term, I would add 1 to the subscript, which is n, so it would be A sub n plus whatever that n is, plus 1. And to go back a term, whatever term I'm talking about, we're just generalizing it here, so whether n is 3, 4, whatever, to get back a term, I'm subtracting 1 from whatever term number that is. So this would be A sub n minus 1. So keep that in mind. We're going to keep practicing. Alright, so here, let's just identify some stuff. So a sub 1 here, hopefully you're seeing is 1, the first term. A sub 4 means we're looking at the fourth number in the sequence, which is 13. A sub 0, that means we need to go back a term. Well, that means we have to know what this pattern is, and we haven't really talked about pattern building yet, but I'm going to go ahead and bring it up. So if you look at what's happening to get from one number to the next, I like to draw arrows. We're adding 4. Hopefully you can see that. So if I'm adding 4 to get to these other numbers, I would add 4 to get to this term. Well, I want to go back 4 to get to this 0 term. So 1 minus 4 is negative 3. So the 0 term would be negative 3. A sub 5, though, if we're looking for the fifth term, we just said to keep going forward, we need to add 4. So we're going to add 4 more, which would be 13 plus 4, which is 17. Alright, so it's all about just manipulating numbers. And then it says, is this sequence infinite or finite? Well, it's got the ellipses at the back with no other number behind them, so this means it goes on forever, so it's infinite. Alright, to infinity and beyond. Think Buzz Lightyear. Alright, on this one, a sub 1 would be the first number, which is 3, first term. A sub 3 would be the third number in the sequence, which we're looking at here is 12. A sub 0, again, we need to go back a term. Alright, so if we go back a term, look at what we were doing to go forward. That's what we need to consider. Well, to get from 3 to 6, you multiply by 2, but we want to turn it to a negative 6, so we need to multiply by a negative 2. And that's going to work for the rest, because look at it. Negative 6 times negative 2 is a positive 12, and then so on. Alright, so if I want to go backwards, I need to do the opposite. So on the other example, we were doing the opposite of addition, which is subtraction. The opposite of multiplication here is division. So I want to divide by a negative 2. And we're just going to leave that as a fraction. A negative 3 divided by 2. Alright. And then it says what term number is 192? Because we've got the ellipses in the middle of the sequence now. There's an actual ending point of this sequence. So first off, it's finite. Finite means it ends. Alright, there's a finite ending. We want to know what term number, what a sub something is 192. Well, let's keep going and see what we can expand on our sequence. So I want to do negative 24 times negative 2, which will be a positive 48. That'll be my next term. Alright, and then I want to multiply that by a negative 2. Alright, so 48 times a negative 2 is negative 96. So that's not the 192 we're looking for. Then I want to multiply by another negative, ooh, I'm writing this backwards. Another negative 2, multiply by it. So we're trying to see if we can hit 192, so we're going to do negative 96 times negative 2, which is going to be positive. It'll be a 192. Well, there it is. So 48 here, if 3 is my first number, negative 6 is my second, this is my third, my fourth. There it goes. 48 is my fifth, 96, negative 96 is my sixth, so this would be my seventh number in the sequence, so it would be a sub 7. And there's another way to figure that out, but we hadn't talked about it yet, so right now you just got to keep going. Alright, here's your practice. So as per usual, go ahead and pause. Write these down, and I want you to find the first term, a sub 1, the fourth term, a sub 4, the 0 term, a sub 0, and tell me whether it's infinite or finite. And when you're ready, unpause it and come check your answers. Alright, here's your first one. It's finite, again, because these ellipses are in the middle of the sequence, so there's a finite ending point. Here's your next one, infinite, ellipses at the end. This one's infinite because it's got ellipses at the end as well. So until next time, keep practicing.